The central dogma. All right, dogma. If you look it up, it just means that it's a core ideal, an opinion that everybody goes by. All right. So the central dogma is that DNA is then converted to RNA and then converted to protein. All right. So your DNA, RNA, then to protein. All right. Central dogma.
Oh.
Now there are two steps. You have transcription and translation. Transcript, T-R-A-N-S-C. The C comes before the L, translation. So transcription is your DNA is then converted to mRNA, okay? Translation, all right, that mRNA is going to be converted into a protein. So they each have steps. The DNA doesn't leave the nucleus. So again, step one, transcription. Step two, translation. Remember, all right, step one is transcription, all right? So you're going to go from DNA to RNA, all right? And there's a process for that, okay? Now, what does that happen? What is the DNA? Of course, you know that is inside of the nucleus, okay? Now, in order for me to get my RNA to going to get my protein, it has to leave the nucleus, okay? So, the DNA leaves the nucleus, all right? So, what's going to happen, all right, the players that are involved in this is DNA and mRNA. Now, mRNA is very important. mRNA is going to give your DNA is going to give mRNA a message, all right? That message is then going to be converted to tell the proteins what to do, okay? So again, mRNA. So what happens? So the DNA is closed, it's not open for people to just do stuff with it, all right? So DNA helicase opens up the DNA. RNA polymerase makes a strand of mRNA, which is a message. That message then leaves the nucleus. Did you hear me? It leaves the nucleus. DNA can't leave the nucleus. That messenger RNA leaves the nucleus, and that is what's going to be translated in the next step. So again, with RNA, remember, A goes with U and G goes with C. All right, so that's the difference between DNA and RNA. RNA, single strand, DNA double strand, but again, that messenger RNA can leave the DNA. Leave the nucleus. Sorry, I was wrong. Let's go. Remember, DNA to RNA to protein, central dogma, all right? The whole purpose of it is go from DNA, RNA to protein, okay? Now, your DNA can't leave the nucleus. We talked about that. So what comes inside the nucleus? The mRNA. How does it get inside the nucleus? It opens up, it's a helicase enzyme that opens up the DNA. The mRNA makes a template, all right? That template is made up of C's and G's, A's and U's because it is RNA. So that message, it has to be translated. But that's DNA message. The message has to be translated into protein so the protein can understand it. As of right now, you have mRNA that cannot be translated because we don't understand it. But a codon is a sequence of three, right? Of three nitrogen bases that code for a protein. So those three, you're going to use a codon chart, which is up to your right. So those three, so for example, UAC, all right, and GCU. UAC is tyrosine, and then GCU, all right, is also amino acid. Those amino acids are the building blocks of protein. So many amino acids make up a protein. So again, mRNA is messenger RNA. It carries the message from the DNA. Okay, the RNA is ribosome RNA, which is in the ribosomes. If you remember way back when, where do we make proteins at? In the ribosomes. So that message is then taken to the ribosomes, all right? And then tRNA is going to be the anticodon. It's going to bring you, all right, the translation, all right? So your mRNA is going to be used to do the codon in those three, and your tRNA is going to connect to it, which is the anticodon, all right, that's going to give you the translation of the message to your amino acids. And then that protein is going to build you, me, Beyonce, Sage, Chase, River, and Carter, and your mama.
What? And Daddy.
Go.
Your mom. Daddy, I have a video with you. I slid. Wait, can we do one more time? One more time.
Genetic code. So once I give you those three codons, it's going to be a codon wheel or a code wheel that cracks the code of the nitrogen bases. So they come in threes. It's going to give you the amino acid which make up the protein is going to crack the code. Okay. Now the last thing, translation. So remember we had step 1 in transcription, 2 is translation. So you go into a new language. I got a couple of students that only speak Spanish, so I'm going to use Google Translate to translate the message from English to Spanish or Russian or whatever the case may be. So translation, mRNA to protein, all right? Where is it located, all right? The ribosomes. If you remember when we talked about ribosomes in your cell and the parts of the cell, ribosomes was what makes protein. It all goes back. The players involved, you got mRNA, rRNA, and tRNA, okay? Remember, once I get it from that DNA, then I got mRNA, which is going to translate that message, and then we'll travel to the RNA, which is going to have the tRNA, which are the anticodons, all right? What happens? mRNA finds a ribosome, because what ribosomes do is going to synthesize protein. All right, mRNA, the codons, the anticodons are going to read. You're going to read the mRNA to bring the right tRNA. The tRNA brings the right amino acid, and the amino acid builds and makes the protein, and the protein is going to make up you, your eye color, skin, and all of that stuff. All right, so again, on your sheet, if you can see it, the AUG would be the codon that it codes for. Now, remember, U goes with A goes with U, C goes with G. It's called the anticodon. It's going to bring the amino acid that's going to build the protein, and that is for protein synthesis at its finest.